Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Br2 in CH3O, methanol, is a halogenation in nucleophilic solvent. Instead of dibromide formation, Br2CCl4, the methanol acts as the nucleophile, giving a bromomethoxy, haloetherification, product. One carbon gets Br and the other gets OCH3. Moving on to the next step. The starting material is a 1,1-disubstituted cyclohexene, trisubstituted alkene. C1 bears H, wedge, H3C, dash, and a CH3 group, with the double bond extending to C2 of the ring. Moving on to the next step. Br2 attacks the alkene pi bond to form a bromonium ion intermediate. The bromonium bridges the two carbons of the double bond. Methanol then attacks the more substituted carbon, Markovnikov selectivity, anti-addition, from the back side, anti to bromine. And for the final step, the bromonium ion forms from one face. Anti-addition means Br and OCH3 end up on opposite faces, trans-anti relationship. Given the stereochemistry of the starting material, H on wedge, H3C on dash at C1, the bromonium forms and methanol attacks anti to give a specific stereoisomer. The product has OCH3 at the more substituted carbon, C1, and Br at C2, less substituted, with anti-stereochemistry. This corresponds to option D. H and CH3 OCH3 on one carbon, CH3 and Br on the adjacent carbon with the appropriate anti-relationship. A. Shows a dibromide-like arrangement without OCH3 at the correct position. B. Places OCH3 and Br on the same carbon which is not the methoxybromination product. C. Shows a vicinal dibromide, no OCH3, which would be the product in CCl4 not methanol. Option D. Correctly shows the bromomethoxy product with anti-addition stereochemistry. Therefore, the correct answer is D. Therefore, the correct answer is option D.